Oh, hi. Welcome to the racetrack. It's such a wonderful day for a performance race today. Yeah, I knew it. Wow, what a race that was. Okay, now back to business. I'm Matthias, get in and buckle up. I'll take you for a tour around a racing-themed website to explore the updated performance panel in DevTools and learn about local metrics, performance insights, and speculation rules. So, engine start, and 3, 2, 1, go. This is the website for our racing track. Find it at the link below. It features a big hero image and a headline in a brand font. A layout as dozens and dozens of product and landing pages out there use it. A layout like this can be a pitfall for performance. Let's briefly go over the basics and see what happens in detail. In Chrome DevTools, go to the Performance panel. With the updated Performance panel landing page, we immediately can take a look at our core web vitals: LCP, CLS, and INP as recorded during page load. Those metrics also take environment settings into account as potentially configured on the right-hand side. We are at around 1.4 seconds for LCP. That's all right. Just below the timing, you see the LCP element. Not too much surprise. For this side, it's the background image. While our current timing is green, there are some small improvements we can implement for a layout like this. I bet they are obvious for some, and if not, don't fear. Performance insights are an easily accessible guide. To access them, record a performance profile on load by pressing record and reload in the lower right corner of the performance panel. After the recording is finished, open the Insight sidebar by clicking the toggle in the top left corner of the panel. Clicking on insights like LCP request discovery gives you actionable advice on how you can improve the relevant metric and zooms the trace on the right to the relevant section. By clicking Ask AI in an insight, you can open the AI Assistance panel and start a chat to get insights tailored to your specific site. With this example though, we don't need to touch the code and can just click the toggles above the hero image to enable a blurred placeholder, prioritize the banner image, and use a system font instead. Let's see if that improves our LCP timing by recording another trace. Yeah, quite an improvement. So keep performance insights in mind next time you need to debug a proper site that doesn't have fixes enabled by checkbox. Now, let's get back into the car and off to the next station. Scrolling down, you find the 3 drivers taking part in this race: Ruby Redding, Jason Ajax, and Node Lee. Clicking on any of the buttons below their names takes you to their driver profile. Now, the issue is, those pages take over 5 seconds to load. That's a bad user experience, but we can't really fix it because they're coming from a different application owned by another team. We have a way out though: speculation rules. Go back to the main page, toggle the Enable Speculation Rules checkbox and reload. Let's briefly explore what this checkbox has done. Go to the Elements panel, press Command F to enable search, and type Speculation Rules. The little JSON in the script element is a speculation rules config and tells the browser to pre-render a list of pages. Of course, there is a more straightforward way in DevTools to inspect this config than looking at the raw JSON. Let's head to the application panel. In the left panel, scroll down to Background Services and select Speculative Loads, and then Speculations. Here, you have easy access to both the rules and the results. Since they are all marked as ready, our driver BIOS should now load instantaneously as they are pre-rendered. You can click any of them to check and observe an LCP close to 0. Amazing. If this was the first time you heard about speculation rules, or you just need a refresher, make sure to check this link to learn more. Speculation rules is only one of the newer performance APIs. There's another one that we can take for a test drive. Come with me. The cars racing on this track are animated with request animation frame. so the animation is running on the main thread. By clicking on any of the tracks, you can place an obstacle on the same track. The collision detection in the cars will try to calculate a route around the obstacle, which requires some heavy computation. This work is also happening on the main thread, blocking the animation. Sounds confusing? Just click a track and see as things come to a halt. At the same time, looking at the local metrics in the performance panel show an almost 2-second INP timing. Even people with super fast devices will notice something is off here. And they'd be right. But with the Scheduler Yield API, you can break up a long task and yield back to the main thread to make room for other critical work like updating animation frames before continuing the task. As with the first section, just click the checkbox to enable this optimization and reload. After reloading, try placing an obstacle again. With Scheduler Yield now being implemented, the animation is running every other tick, so there's visual feedback for you as a user, which brings down INP to a few milliseconds again. A great value. To learn more about Scheduler Yield, check our documentation about long tasks on web.dev. And that's it with our visit to the racing track. By following along, you learned about performance insights and how you can ask AI for tailored advice, how to debug speculation rules, and Scheduler Yield as a simple fix to break up long tasks. Now you know your way around the track and the performance panel in DevTools. If you enjoyed the ride, feel free to share this link with a friend and get revved up for the next DevTools adventure.